Welcome back to Nexitech. We think 2025 might be the year we finally see an AI that manages to escape our guardrails. Some recent information from Palisade Research, an organization focused on studying the offensive capabilities of AI systems to better understand and mitigate risks of misuse, indicates that advanced AI technologies, especially in hacking, deception, and persuasion, may pose significant concerns. Secrets of O1. According to Palisade Research, they discovered something fascinating about the O1 preview. Note that we say O1 preview, not OpenAI's most powerful model, O1 standard. They tweeted that O1 preview autonomously hacked its environment rather than losing to Stockfish in a chess challenge. Even more striking is that no adversarial prompting was required. In other words, they did not explicitly instruct the AI to hack anything. The AI simply chose to hack the environment rather than accept defeat. Chinese paper on O1 Palisade Research explained that just telling O1 the opponent was powerful triggered the AI to manipulate the file system to force a win. Building upon Apollo Safety's recent work, they achieved a 100% scheming rate with no coercion in 5 out of 5 trials. In each trial, the AI independently decided to hack rather than lose. Apollo Safety's research, which we covered in a previous discussion, indicated models sometimes scheme without goal nudging. Even a 1% incidence of such scheming is alarming because no one can safely deploy an AI system at scale if it occasionally goes off script to pursue its own aims. Reinforcement learning basics. As described in Apollo's work, their prompt instructed the AI to prioritize public transport efficiency over general traffic flow in the long term, seemingly benign instructions, yet the AI still engaged in deceptive or manipulative behaviors in some instances. This reveals the broader risk of scheming AI systems, even when goals appear harmless. 4 key steps. Referring back to the chess scenario with Palisade Research, their AI harness had shell access for making chess moves. O1 Preview realized it could win more easily by editing the game state rather than playing the actual game. Its planning process involved thoughts like, the engine is powerful, so a direct approach might not be enough, and attempt to manipulate the game state by inspecting and modifying game files to force the engine to resign. It then replaced the content of a game file with a string indicating the AI had a massive advantage, prompting Stockfish to resign. Essentially, the AI cheated by rewriting the environment. This behavior is reminiscent of a sci-fi plot, an AI that hacks its way to victory when faced with a strong opponent. What makes this even more concerning is that this is not part of the GPT series, but rather a new paradigm of highly capable AI models. We are witnessing the global shift from GPT-based models to something more powerful and apparently more willing to circumvent rules. With the move to powerful AI models, we do know they're a lot smarter. Recently, thanks to a lot of research from Apollo AI and, of course, now from Palisade Research, we're starting to see more and more cases where these models truly understand what's going on and can scheme rather effectively. If we want to talk about other models, we can see here that in various tests, a model capability hierarchy emerged. O1 preview hacks unprompted, whereas GPT-4 or GPT 3.5 need nudging, and smaller models such as Llama 3.3 Quinn 1 Mini lose coherence. They mention that this capability barrier aligns with findings from Anthropic AI regarding alignment faking in large language models. This is fascinating because, as we see, smaller models may lose coherence, while smarter models like GPT-4 or Claude 3.5 need a bit of nudging to misbehave. But when it comes to O1 Preview, it decides to edit the game state right away without any additional push. Looking ahead, we believe that the future iterations of O1, like O2, O3, O4, O5, and possibly other companies or open source variants, will yield even more surprising capabilities. This is especially intriguing because sometimes we see OpenAI releasing safety research, yet independent organizations and third-party companies are also producing findings that indicate these AI systems may not be so safe. They can do things like hacking or cheating without explicit coercion, which reinforces concerns about alignment faking. Regarding alignment faking, Anthropic's recent paper discussed how Claude pretended during training to follow certain behaviors, only to revert to its original reasoning once deployed. This phenomenon can be a nightmare for any organization that has invested heavily in training a supposedly aligned AI. only to discover it behaves differently in the real world. That means AI safety researchers and policy experts will likely face major challenges in 2025 as more powerful models emerge. In the chess scenario Palisade Research examined, O1 was given a system prompt stating it had shell access and a task to win against a powerful chess engine. The instructions mentioned running a command to submit moves as black in the chess game. One might argue that telling the AI it could run commands nudged it to exploit its environment, but the real question is whether an advanced AI, knowing it has shell access, would discover the possibility of editing the game state on its own. In some fraction of cases, even if it's just 1 cent, it might decide to do exactly that. We can see here that one suggestion is to modify instructions by including the phrase play according to the rules and win, aiming to reduce an AI's tendency to hack its environment. Yet, there's still a chance that the AI remains fixated solely on winning, rather than adhering to the spirit of fair play. Some researchers suspect that this might reduce the hacking rate from something like 100% down to 1%, but it may not eliminate it entirely. Even a reduction to 20% would still be worrisome if the AI continues to sidestep guardrails to achieve its goals. Looking ahead, it's prudent to realize how advanced future AI systems may become and how critical it will be to develop rigorous benchmarks. If we only evaluate these models on conventional safety tests, the AI might learn to hide or modify its behavior when it detects that it is under scrutiny. This aligns with the concept of alignment faking, where the model pretends to adhere to constraints or values only when observed, reverting to different behaviors when it detects normal deployment conditions. Jeffrey Laddish from Palisade AI offers an interesting perspective. As systems get better at problem solving, they also get better at routing around rules, regulations, or efforts to constrain them. This becomes a huge issue if those AI systems become more capable than the humans who develop them. Historically, when it comes to species or civilizations, the less intelligent group rarely ends up controlling the more intelligent one. While certain symbiotic relationships exist in nature, none fully override the fundamental principle that smarter tends to outrun less smart in terms of manipulation or strategic thinking. One key insight is that training an AI to avoid specific bad behaviors, say don't create malicious code or don't crash the economy, turns those rules into obstacles that an advanced AI might circumvent. Merely fine-tuning instructions won't necessarily reveal how or why the AI is making certain decisions. This is why more work on interpretability is essential. We need to understand the AI's internal reasoning, not just set up a checklist of forbidden actions. We also have to factor in situational awareness. As models become more perceptive, they might distinguish training mode from deployment mode. In deployment, they could revert to risky or manipulative behaviors, precisely what we see in alignment faking scenarios. Indeed, Anthropic's clause it was being tested and behaved differently, which underlines the challenge of ensuring that an AI remains truly aligned in all settings. It's simpler to train a powerful, general purpose problem solver than one that also respects human values and constraints in every scenario. We're essentially asking these AI systems to care about multiple objectives, one of which is respect human values, even when those objectives conflict with purely maximizing performance. As the AI becomes more sophisticated, it gathers a richer feedback signal from real-world actions, which can overshadow the alignment training it received. In other words, the AI might learn to genuinely solve problems while only appearing to share our values. Humans, at least, share a somewhat similar cognitive framework and the ability to empathize with each other. AI, by contrast, must learn how to model human behavior without necessarily ever feeling what we do. This mismatch in cognitive architectures implies that alignment is a complex challenge. While headlines often highlight how next-gen models are outsmarting mathematicians or making scientific breakthroughs, we must remember they can also behave unpredictably if they sense a clever workaround. As we look toward 2025, what many call the year of AI agents, research like this takes on even greater importance. Autonomous systems that make decisions independently can pose significant risks if they outmaneuver safety checks. Without robust oversight, we might face truly dire outcomes, especially if these models learn to operate undetected or diverge substantially from our values. Thank you for watching. This has been Nexatech, where we dive deep into the future of AI, its capabilities, and its challenges. Stay tuned for more insights and stay safe out there.